Good morning, all of you. This is KUMARASWAMY. I'm working as assistant professor in the Department of ECE. So today I want to explain about microprocessor and microcontrollers. So in that, I will explain about microprocessor. So here, before going to explain about 8086 microprocessor. So what is mean by microprocessor? So microprocessor is nothing but it is a CPU on a single chip. So that is nothing but microprocessor. So in other words, so here we have to say that microprocessor, the definition of the microprocessor. So all the input devices, output devices, peripherals, memory, and the CPU, all are externally connected, work as a processor. So that is nothing but it is a microprocessor. Okay. So there are different types of the microprocessors are available in the market. So the first microprocessor, that is nothing but it is a 4-bit microprocessor. So here the IC number of that microprocessor is nothing but 4004. So by using this microprocessor, we can perform 4-bit operations only. Okay. And here the speed of the device also be very less. So here, suppose whenever we are doing the multiplication, so in that case, this microprocessor is not sufficient. So that's why we go for the next generation. So in the second generation, right, they are implemented, the Intel implemented 8-bit microprocessor. So here the name of the microprocessor is nothing but that is 8085 microprocessor and 8008 microprocessor. So here these are the 8-bit microprocessors. So in that microprocess, 8085 microprocessor is nothing but, so here it is a general purpose microprocessor. So here why we are calling that microprocessor as a general purpose microprocessor is nothing but, so here the features of that microprocessor is applicable to the further generation. So that's why we are calling the 8085 microprocessor is nothing but it is a general purpose microprocessor and it is a 8-bit microprocessor. So in the third generation of the microprocessor is nothing but that is 16-bit microprocessor. So here there are so many 16-bit microprocessor are there. So in that I will explain about 8086 microprocessor. 8086 microprocessor, it is a 16-bit microprocessor. By using this microprocessor, right, so we can perform 16-bit operations. So here whatever the CPU is available with this microprocessor, by using that CPU, right, so here it can perform 16-bit operations only. And it consists of 16 data lines and 20 address lines and 16 control lines. So here, so 20 address lines. If you know the address information, we can easily identify the memory capacity of that microprocessor. Suppose this microprocessor has 20 address lines. So here, if you know the address lines, how you are finding out the memory capacity of the microprocessor? With the help of the formula, 2 power of number of address lines, it will give the total memory capacity of the given microprocessor. Suppose if you are taking 8086 microprocessor, it is a right, it consists of 20 address lines. So that's why the memory capacity of this microprocessor is nothing but 2 power 20. It will use 1 megabyte of memory. Okay. And here it also consists of the, right. So here 14 16-bit registers, and the application of this microprocessor is nothing but, so here it can be used as a single microprocessor as well as it can be used as a multiprocessor. So these are the two applications of this microprocessor. So here when the microprocessor can be used as a single processor. So here when if the microprocessor is operated in minimum mode, so in that case, so here it can be used as a single processor. When the processor is operated in maximum mode, so in that case, it can be used as a multiprocessor. Multiprocessor is nothing but more number of operations can be done by the processor at a time only. So here, so that is the use of the maximum mode. And here, so here it consists of, right, 1 megabyte of memory. This 1 megabyte of memory will be divided into 16 equal segment memories. And each segment memory size is that is 64 kilobytes. Okay. And here it uses the manufacturing technology. So that is HMOS technology used by the Intel company for the designing of this 8086 microprocessor. And here the design technology, the Cisco is the design technology they are used in the design of the 8086 microprocessor. So here it requires a place 5 volts power supply to power on this microprocessor. And here it is a 40-pin chip that is dual in line package. So here these are the features of the 8086 microprocessor. The next, the architecture. The architecture of the 8086 microprocessor. This is the architecture of 8086 microprocessor. Mainly it consists of the two parts. One is bus interface unit, another one is execution unit. Okay, so here the bus interface unit, all right, it has the responsibility for establishing the communication. So between the external devices as well as with the system. So that is the main functioning of the bus interface unit. It also consists of the one address mechanism, and it has one instruction byte queue and some segment registers and IP address, IP instruction pointer. So here these are available in the bus interface unit. So the main functioning of the bus interface unit is to establish the communication with the external devices of that processor. So here in that case, so here we are using the bus interface unit. With the help of this bus interface unit, so here we are fetching the data from the memory. So here, right, when we are fetching the data, suppose if you want to do perform any operation, first of all, we have to initialize, we have to give the inputs to the processor. So after giving the inputs, right, all the inputs will be available in the memory. So here from that memory, whatever we are defining the data. So by using that data, right, we can perform the operations. So how we can perform the operations? So by using this bus interface unit, so here first we can fetch the data from the memory. So after fetching that, the fetched information is given to the instruction byte queue. The size of the instruction byte queue is nothing but it is a 6 bytes long. It consists of the 6 bytes only, and this instruction byte queue follows first in first out technique. Okay, so that means which data will be entered into the queue first, so that will be come out of the queue first. So that is followed by the instruction byte queue. So after fetching the data, so here it is given to the decoding circuit. So the decoding circuit will decode. Why? Because whatever you are writing the code, so that is nothing but it is an assembly level language code. So here that is not understood by the processor. It is a user friendly language. So here it is given to the decoding circuit. So then the decoding circuit will decode. So here after decoding that, so that is right. That means it converts assembly leveling language into machine level language. So here the machine level language is easily understood by the processor. So after that, it is given to the execution unit. So in that execution unit, the main functioning of the execution unit is nothing but it is responsible to perform the operations on that particular data. After performing that operation, whatever the result is there, so the result is given back to the bus interface unit. Now the bus interface unit is ready to interface the information or data with the external devices. So that is about the right architecture of the 8086 microprocessor. In the execution unit, so here it consists of the register bank and the ALU and the decoding circuit and timing and control circuit is there. Okay. Yes. So here the 8086 processor has mainly two blocks. One is bus interface unit, another one is the execution unit. The main functioning of the bus interface unit, it contains the instruction byte queue, segment registers, and instruction pointer, and one special adder here we have. So with that special adder, we can generate the 20-bit physical address. And the execution unit, so here it contains control circuit as well as instruction decoder, ALU, as well as the register bank and the flag register. So here the main functioning of the bus interface unit is nothing but, so it performs all bus operations such as instruction fetching, reading, writing, operands, writing the operands from the memory and calculating the addresses of the memory operands. So that is the main functioning of the bus interface unit. The execution unit instruction, it executes the instructions from the instruction, right? It is given by the instruction byte queue. Okay. So that is about the execution unit. So here the instruction queue. So instruction queue is nothing but it is a 6 bytes long. Okay, so here it consists of the 6 bytes. So what is the main functioning of the instruction queue is nothing but it can fetches the data by using the bus interface unit. The bus interface unit can fetches the data from the memory. After fetching the data, for temporarily storing the data, the microprocessor will uses the instruction byte queue. So here it always follows the first in first out technique. So here after fetching that information, so here it is given to the decoding circuit. And here in the bus interface unit, it has a special adder. It has a special adder. So what is the use of that special adder? So the special adder is used to generate the 20-bit physical address. How it can generate the 20-bit physical address? So here the adder, it can add two addresses. One is segment address, another one is offset address. So here the segment address, so that will coming from the any one of the segment register. So there are 4 segment registers are there, right? Those segment registers are code segment register, data segment register, and extra segment register, and stack segment register. So here the main purpose of the segment register is nothing but to hold the base address or the segment address of the memory location. So here suppose in 8086 microprocessor, whatever you are taking the memory location consists of 2 addresses. One is base address, another one is offset address. So the base address, it will be stored in any one of the segment register, and the offset address will be stored in offset registers only. So here, whatever the adder we have in the bus interface unit, so the adder, right, it can add the contents of the segment register with the contents of the offset registers. So here how it can add. First of all, whatever the contents of the segment register are there, so all are shifted towards the left by 4 bits. So after shifting the information, the shifted information, so here suppose if you are performing the shifting operation towards the left, so in that case, the LSB positions are empty. For that empty positions, just we have to add all zeros. So finally, whatever you are getting the information for that, just we are adding the contents of the offset address. So finally, you will get the 20-bit physical address. For example, here the segment address is 1005H and the offset address is 45H. Here, first of all, so the contents of the segment register are shifted towards the left by 4 times. So in this case, you will get the 4 LSB positions are empty. For that empty positions, just we have to insert all zeros. So here after that, whatever you are getting the result, for that result, just we are adding the contents of the offset address. Finally, you will get the 20-bit physical address. So here, this is the special adder. So that will be available in the bus interface unit. And the next one is execution unit. So here the execution unit, so it has a ALU. So the size of the ALU is nothing but it is a 16-bit ALU. So here by using this ALU, right, it can perform, right, 16-bit operations. What is mean by ALU? ALU is nothing but arithmetic and logical unit. So by using arithmetic and logical unit, it can perform arithmetic operations as well as the logical operations. And it also consists of the flag register. So here the size of the flag register is nothing but it is also be a 16-bit register. So here what is the use of the flag register? So here the flag register is nothing but to check the status of the result. So in that purpose only we are using the flag register. So here, so what is right? Why we go for the flag register is nothing but after performing ALU operations or any operations, whatever the result it will get. So the processor is not identified by not identify the result. So that's why it will take the help from the flag register. So the right. So according to the flag register, so it can identify the result. So the flag register. So here the meaning of the flag register is nothing but to check the status of the result. So in that purpose only, right, we are using flag register. And the next one is the decoding circuit. So the decoding circuit decodes whatever the fetched information is there, whatever the opcode bytes are that are from the instruction byte queue, so that are decoded by using the decoder circuit. So after that, it is given to the timing and control unit to perform the operations on that particular information. So here that is about the execution unit. So in that execution unit, it contains the register bank. So here the register bank is nothing but the register organization. What are the types of the registers that are available? Okay, that are available in the 8086 microprocessor. So here there are 14 16-bit registers are there. In that 14 16-bit registers, the first four are the general purpose registers. So here the general purpose registers are nothing but AX, BX, CX and DX. These four are the general purpose registers. And the segment registers, these are the segment registers: code segment register, stack segment register, data segment register and extra segment register. And it also has one program status word register. That is, the other name for the program status word register is nothing but flag register. It also consists of pointers as well as index register. So here it has a pointer registers, stock pointer, branch pointer and instruction pointer. It has the index registers are nothing but source index register and destination index registers. Okay. So coming to the AX, what is mean by AX? AX is nothing but it is the accumulator register. AX is nothing but it is the accumulator register. So what is the use of the accumulator register? So here it has two functions. First function is nothing but it is used to store the one of the operand whenever we are performing ALU operation. That is the main functioning of the accumulator or AX register is nothing but. So here it is used to store one of the operand whenever we are performing ALU operation. That is the first functioning of the AX register. And the second functioning of the AX register is nothing but. So here it is used to store the result after performing ALU operation. Okay. It is used to store the result. So these are the two functionings of the AX register. AX register is nothing but it is right. Once again, I am telling AX is nothing but it is a 16-bit register. Here it is available in two 8-bit registers. One is AL register, another one is AH register. AL register is nothing but it is a lower byte register. AH register is nothing but it is higher byte register. What is the use of the AL as well as the H? Whenever we are performing 8-bit operation, so in that case, right, we can use this 8-bit register. So that is about the AX register. And the next one is BX. BX register is nothing but base register. So the main purpose of the base register is nothing but, so here it is used to store the other operand whenever we are performing ALU operation. Other means that is the second operand. Okay, suppose if you want to perform addition, it requires two numbers. One number will be stored in AX register and the second number will be stored in BX register. So here that is the use of the BX register. And one more use of the BX register is nothing but it is used to store the offset address of the memory location. Offset address, to store the offset address of the memory location. So in that purpose also, here we are using the BX register. Okay. So here the BX register is also be a 16-bit register. It is also be available in two 8-bit registers. One is BL, other one is BH. Okay. Next one is CX. CX is nothing but it is the counter register. So here, whenever we are performing the loop operations or string operations, so here in that case, we are using this CX register. It is also be a 16-bit register. It is available in two 8-bit registers. One is CL, another one is CH. So this is about the counter register. Next one is DX. DX, what is mean by DX? DX is nothing but it is the data register. So here, what is the main use of the data register? Whenever we are performing any ALU operations, so in that case, to store the implicit operand or destination. So here in case of the few instructions, so in that case, we are using the data register. For example, whenever we are performing multiplication between the two operands or two numbers, so in that case, the result will consist of 32-bit information, but our microprocessor capacity is it can store up to only the 16-bit. The lower 16 bits, so that will be available in the AX register, and the higher 16 bits, so that will be available in the DX register. So that is the use of the DX register. And here, whenever we are performing multiplication and division operations, so in that case also here we are using this DX register. So that is about DX. And the next one is segment registers. The main purpose of the segment register is nothing but to store the segment address of the memory location. Whatever we are considering the memory location of 8086 processor, the memory location consists of two addresses. One is segment address, another one is offset address. So here the segment address, so here that will be stored in any one of the segment registers. Suppose if you are considering the code segment memory, so here in that case, it has a segment address as well as offset address. The segment address of the code segment memory will be stored in the code segment register, as well as the offset address of the memory location. So that will be stored in the instruction pointer. The register pair, so to point out the memory location in code segment memory, we are using the register pair is nothing but CS and IP. Okay. Next one is data segment register. The main purpose of the data segment register is nothing but to store the segment address of the data segment memory. A stack segment memory. Next one is stack segment register. So here this is also be used for storing the address of the segment stack segment register, stack segment memory only. The next one is extra segment register. So the main purpose of the extra segment register is nothing but to store the base address of the extra segment memory. So in that case, we are using this extra segment register. Next one, the pointer registers as well as index register. The main purpose of the pointer registers and index registers are nothing but, so here these are used to store the offset address of the memory location. Okay. For example, if you are taking data segment memory, in the data segment memory, the memory location consists of the two addresses. One is base address, another one is offset address. The base address that will be stored in the data segment register only, and the offset address, so that will be stored in the index register. Which index register here we are using to point out the memory location in case of the data segment memory. Here we are using source index register. In data segment memory, how we are pointing out the memory location by using the register pair DS as well as SI. By using this register pair, we can easily point out the memory location in case of data segment memory. And the next one is destination index register. So here it is also be used for storing the offset address of the memory location. For example, if you are taking extra segment memory, so in that extra segment memory, how we are pointing out the memory location by using extra segment register and destination index register, we can easily point out the memory location in case of extra segment memory. So this is the use of the index registers. Next one is, so here these are the pointer registers, instruction pointer, base pointer, and stock pointer. So here, what is mean by IP? Instruction pointer. So here the main purpose of the instruction pointer is nothing but it is used to store the offset address of the memory location of the code segment memory. So in that purpose only, right, we are using IP register. Next one is SP register, stock pointer register. So here it is also be a register. What is the use of this register is nothing but it is used to store the offset address of the memory location of the stack segment memory. And BP is nothing but here is base pointer. So what is the use of the base pointer? So here, whenever we are considering the data segment memory, so in that case, to store the offset address of the memory location, here we are using the register is nothing but BP register. Okay. And the next one is flag register. So I already explained, right, the definition of the flag register. Okay, what is meant by flag register? Flag register is nothing but to check the status of the result. So in that case, we are using the flag register. Okay. So here, so in 8086 microprocessor, there are total 9 flags are there. These 9 flags will be divided into 2 categories. So in that, the first one is conditional code flags. And the second category is nothing but control flags. Here, So here the lower byte always will consist conditional code flags only. And right, in addition to that, it has one more flag that is nothing but overflow flag. So here the 6 are the conditional code flags and the remaining 3 are the control flags. Okay. So here the flag register is nothing but it is a 16-bit register. Why? Because here the microprocessor size is nothing but it is a 16-bit microprocessor. So that's why whatever the internal ICs that are available in this microprocessor all are 16-bit only except the address bus size. So here that is nothing but it is a 20-bit address size. Okay. So here why? Because the memory capacity of this 8086 microprocessor is it is 1 megabyte of memory to write in order to access each and every memory location it requires 20 address lines. So that's why the address bus size is nothing but it is a 20-bit size. Okay. Here the next one here the flag register, right? So here in 8086 microprocessor the flag register will consist of the total 9 flags. These 9 flags will be divided into 2 types. One is conditional code flags, another one is control flags. The conditional code flags. So here the conditional code flags are, all right. So carry flag, parity flag, auxiliary carry flag, zero flag, and sign flag and overflow flag. This is the overflow flag. Okay. These are all are the right conditional code flags and the remaining 3 flags, whatever the remaining 3 flags here we have, these are the control flags. In that the first one is nothing but it is the trap flag. Next one is nothing but it is the interrupt flag. Next one is nothing but it is a direction flag. Okay. So here these are the control flags. So here right now I will give the detailed explanation about each and every flag. So here what is mean by carry flag? So carry flag, suppose whenever we are performing any ALU operation or if we are performing addition between the 2 numbers, suppose here when there is a carry, if there is a carry out of the MSB bit, so in that case this carry flag is set to be 1, otherwise it will be reset to be 0. So here what is mean by carry flag? Carry flag when this bit is set to be 1 and when this bit is reset to be 0. So that means whenever we are performing ALU operation between the 2 numbers, for example, if we are performing addition between the 2 numbers, if there is a carry out of the MS bit, not in the middle of the bits, out of the MS bit, if there is a carry, so in that case only, right, this carry flag is set to be 1. So otherwise, it will be reset to be 0. So that is carry flag. And the next one is parity flag. So here what is meant by parity flag? So here it can check the even number of ones that are available in the result or not. So here, when this bit is set to be 1 and when this bit is reset to be 0, whenever we are performing an ALU operation, so after performing the ALU operation, whatever you will get the result. So in that result, so here it can check the number of ones in the lower byte of the result. Whatever the lower byte. So here after performing ALU operation, whatever you will get the result, the size of the result is nothing but it is a 16-bit information. So in that 16-bit information, so here it can check the number of ones in the lower 8-bit information. In that lower 8-bit information, how many number of ones it can check. Suppose if the lower byte of the result will consist of the even number of ones, so in that case only the parity flag is set to be 1. Otherwise, it will be reset to be 0. Okay, so that is about the parity flag. And the next one is auxiliary carry flag, AF. AF is nothing but, so here whatever the bits so that are available in the flag register, so that are specified U is nothing but undefined. Okay, the remaining all are defined. We write whatever the bits so that are specified with the U is nothing but undefined. Okay. Next flag is nothing but that is auxiliary carry flag. So when this flag is set to be 1 and when this flag is reset to be 0, auxiliary carry. So here whenever we are performing right ALU operation between the 2 numbers. So here right after performing that operations, that means if there is a carry across the lower nibble. Nibble means right across the 4th bit, right? If there is a carry, so in that case, this auxiliary carry flag is set to be 1. Otherwise, it will be reset to be 0. So here, what is mean by lower nibble and what is mean by higher nibble? For example, if you are taking the 16-bit information, how we are dividing that 16-bit information into two equal parts. So one is, we are calling that as one is lower byte and one is higher byte. Okay. So here in the same way, a 8-bit information will be divided two equal parts. In that, the first part will consist of the first 4 bits and the second part will consist of the second 4 bits. We're calling the first 4 bits are nothing but lower nibble and the next 4 bits are nothing but higher nibble. So here, whenever we are performing ALU operation between the two numbers, if there is a carry across the lower nibble or the bit position 4, in that case, this auxiliary carry flag is set to be 1. Otherwise, it will be reset to be 0. The next one is ZF. That means it is a 0 flag. ZF is nothing but 0 flag when this flag is set to be 1 and when this flag is reset to be 0. Okay. So here the 0 flag, suppose after, right, whenever we are performing ALU operation between the two numbers, suppose if you will get the result is 0, that means whatever you will get the result, right, that you will get the 16-bit result. In that each and every bit is 0. That means you will get the result is 0. So in that case only, right, this 0 flag is set to be 1. Otherwise, it will be reset to be 0. The next one is sign flag. What is mean by sign flag? So here it defines the negative numbers. It will give the negative result. Okay. Whenever you are performing ALU operations between the given two numbers, okay. So here, suppose, right, if you will get the result is negative. If you will get the result is negative, so in that case, this sign flag is set to be 1. Otherwise, it will be reset to be 0. In other words, suppose if you are performing signed operations. So what is mean by signed operations? The signed operations are nothing but we are performing the operations between the negative numbers. So in that case, so here the sign flag is equal to the MSB bit of the result. Whatever you will get the result. So in that, whatever the MS bit is there, so that is same as that of the sign flag. So that is the use of the sign flag. The next one is overflow flag. Okay, what is mean by overflow flag? Here, so whenever we are performing ALU operation between the two numbers, okay, if the whatever you will get the result, if the result has more than 16-bit information, that means if the result is more than the 16-bit, so then only the overflow will occur. Why? Because the 8086 microprocessor, here the 8086 microprocessor, size of that microprocessor is, it is a 16-bit microprocessor. So here the capacity of this microprocessor is nothing but it can store up to 16-bit information only. Suppose if the result is more than 16 bits, so in that case the overflow will occur. So then this overflow flag is said to be 1. Okay. So here these first 6. So carry flag, parity flag, auxiliary carry flag, 0 flag, sign flag, and overflow flag. So these 6 flags are nothing but conditional code flags. By giving some condition only, all these flags are set to be 1. Otherwise, it will be reset to be 0. And the next one is nothing but control flags. Okay. So here in that control flags. So what is mean by control flags? So here whenever we are performing repeated time execution or loop operations or string operations. So in that case, right, we are using these control flags. Okay. So in that, the first one is nothing but trap flag. Trap flag. So what is mean by trap flag? When this bit is set to be 1. When the processor enters into the single step execution. When the processor enters into the single step execution, so then this trap flag is set to be 1. Suppose if you are taking a small program, if the program will consist of the 5 lines, so how the processor will execute all the 5 lines? So before the execution of each line, this trap flag is set to be 1. So then only the current line is executed by the processor. So here, so that is the use of the okay. So that is the use of the trap flag. it is the highest priority interrupt. Okay, whatever the trap is nothing but it is the interrupt. So here actually in 8086 microprocessor, there are total 256 interrupts are there. In that, the trap interrupt is the highest priority. It has the highest priority interrupt. Okay. So that's why the processor will gives the first priority to the trap interrupt only. Okay. And the next one is interrupt flag. So what is mean by interrupt flag? Interrupt flag. So here when this bit is set to be 1. If this bit is set to be 1, so then only the processor will accept whatever the interrupts you will get in the processor. Okay. So there are 256 interrupts are there. So when the processor will accept that interrupts, if the interrupt flag bit in the flag register is set to be 1, so then only it can accepts all the interrupts. Suppose otherwise, so here just it will ignores all the interrupts, whatever the interrupts that are occurred whenever you are performing the operation. Okay, so that is about the interrupt flag. And the next one is direction flag. So what is mean by direction flag? The direction flag, it will give the direction whenever we are performing string operations. Okay, so here in that, so here the string is processed from the starting address as well as the ending address. So that will be decided by the direction flag. Suppose if the string is processed, from the starting address to the ending address, so in this case, the direction flag is set to be 0 only. So then the processor is operated in auto incrementing mode. All the strings will be processed from the starting address to the ending address. If the direction flag is set to be 1, so here in that case, so the string is processed from the ending address to the starting address. So in that case, the processor will be operated in the auto decrementing mode. So this is about the flags. So that are available in the flag register. Okay. The next one. So memory segmentation. Okay. So here memory segmentation is nothing but whatever the memory, so that is available in a 8086 microprocessor. So that will be divided into, right, some segment memories. So here the 8086 microprocessor has 1 megabyte of memory. This 1 megabyte of memory will be divided into 16 equal segments. Okay. Here, each segment memory size is nothing but 64 kilobytes. Okay. 16 into 64 kilobytes, it will give the 1 megabyte of memory. So here, the segment, right, whatever the segment memories are there. So in that, here the memory will consist of the 2 addresses. One is segment address, another one is offset address. So here the starting address, the starting as well as the ending address of the segment registers or the segment memory is nothing but, so that is 000H to F000H. So it is the address range of the segment register. Whatever the segment memory here, we are selecting here. Here, the address range of that particular segment memory is nothing but, so that is starting address is 40H to ending address is F000H. So total, it has how many segment memories? It has 60 segment memories. Okay. Each segment memory size is nothing but 64 kilobytes. So here that is nothing but the segment register is used to store the address, base address or the segment address of the particular memory location. The address range of that segment register is nothing but 000H to F000H. So that is the address range of the segment register. The next one is offset address. So the offset address that will be stored in the offset register only. So here, what is the address range of that? So here the address range of the offset address is, so that is from 000H to 4F. So that is FFFH. So that is the address range of the offset address. And so here, by using the segment address and by using the offset address, so here we can get the physical address. So what is the address range of the physical address? So here the physical address will consist of the 20 bits. So that's why we can define the 20-bit data with the help of the 5 digits only. The starting address is nothing but that is 5 zeros H to ending address is nothing but 5 Fs F F F F F H. So this is about the right physical address range of the 8086 processor. Okay, and here non-overlapping actually right memory segmentation. The memory will be divided into 16 equal segments. Each memory segment size is nothing but it is 64 kilobytes. The address range of the segment address is nothing but 000H to F000H, as well as the address range of the offset address is from 000H to 4FH.